How's it going, everyone? We're Gonzalez again, exploring the RxJS, which is now part of the asynchronicity in JavaScript. And how, as a JavaScript developers, do we handle that? So, because all of this start by asking a question: is that what Redux is? So this is state management for any JavaScript applications, and the idea to have this kind of tool or abstractions is to give us the ability to now keep track state change. In other words, when a particular object's property change, we can now have that ability to provide now these useful features like time travel debugging, for example. So you can see what's going on before that happened. And since Redux API has several methods and property, one of them is especially when Redux actually based on the Flux architecture. So this is now the architecture in which by using is now the actions, the reducer or the dispatch and the state to update the view, and then this is now a feedback loop that happens anytime now a user changes the UI or interact with the UI and modify a particular state. So for example, in a button or in an input, right? So if you click on a button, what is the color you want to show? What is the action that you want to provide, or the UI feedback you want to show to the user? But because of that, since natively we don't have any mechanism for doing that, we have to rely on these particular abstractions, right? Like Redux. So Redux now uses the Flux architecture, and because now you can extend is the functionality of this, whether it is by enhance the Redux store or by adding middlewares, where you want to enhance the store is by now providing features like the time travel debugging. And if you want to now add middleware or this function that sits in this case between now the action and the reducer, all right? So this is something where you put your async logic here in this middleware. So it detects now the actions, and then once that is done, it now after that you can update the state. That's the whole point of this. That's the premise, and this is something that the Redux maintainer, right, actually point that out. So the Redux, oh my God, Jesus, Redux here, advanced Redux, right? Okay, we get it. Chill. With advanced Redux, especially not advanced Redux, because we would like is to now look at the Redux fundamentals, and then we can move on to the Redux to understand this. So in this course of Redux API, we look at again the different API or method that it exposed this Redux, these abstractions. So apply middleware, compose, combine reducers, bind actions creator and create store. This actually create now these objects. The compose is allow you to now is pass functions. So you can now by running all of these functions, you're gonna get a particular output, which is helpful when you use now with the combined reducer. In other words, it's like you're going to add all of this reducer or all of this state update logic that is gonna update a particular state for that. And then the bind actions creator. This is a way to actually simplify the redundancy that you when you create your actions following in the Flux architecture, which is the actions object that you need to generate that must follow is this format, which is the type and the payload, right? And then on the apply middleware, okay, is when you, as I mentioned before, you can now add that. So here, this is a couple example of middlewares. And remember that middlewares intercept actions to add behavior between the dispatch and the reducer. Okay, it chains together with apply middleware, which is the functionality that we look at this, and it runs during the dispatch process. So anytime you want is to now update an state on the dispatch, so this middleware is gonna run. So it runs before the reducer and after the reducer. So you can choose when to go with. And you can change middleware easily. The idea here is to now have the ability to add this particular logic at this point before updating the state or after, but usually before. So, because now with this middleware we can have access to the store and the next and the actions, right? As you can see, this is a function that calling another function, another function, another function. Here, one of the main use case for this is for logging behavior or logging action. So here you can detect now, hey, this is the action that happens, so I can send that to a, for example, monitoring tools like Sentry, performing side effects like routing and turning an async API call into a series of synchronous actions. So the famous use case of middleware is Redux RTK. So it's important to understand that, because you might wonder is, okay, as we create our own middleware, okay, and because this Redux RTK, let's say you hypothetically make an AJAX request in this middleware, or you want to fetch some data, all right, you want is to now, your middleware can intercept that actions, fire the promised AJAX request, fire the real action afterward. That's the idea here. So intercept that action, fire the promised AJAX request, wait for that promise to be completed, and once that is done, fire the real actions afterwards. Once you get that, usually that's how Redux thunks actually work. And then we get into the thunks. So what is a thunk? This is when we need to understand a synchronicity before that. And that is the reason we actually take this from that. So yeah, this is just to explain that a little bit, and actually a thunk exercise, right? But all of this was because, or understand now, how do we get to Redux, right? Okay. Okay. So, bear with me. I'll be right back. All right, and we're back. Now, after that quick pause, and also to explain now what is thunk, and that's when we get into this rabbit hole, right? So, well, because of that, and because I didn't understand 3 months ago what was thunk like this, all right? That's when I need to go into the rethinking asynchronicity in JavaScript. This is a course taught by Kyle Simpson as a way to understand now how asynchronicity. So first, we're gonna get a conceptual understanding of asynchronicity patterns, right? This stuff that happens recurrently. So these are synchronicity patterns and practice on what we do the things. So the TLDR is to understand that how can we handle is asynchronicity on the language. And as a JavaScript developers, it is important to make a quick recap of now certain fundamentals, especially how programs are executed, what is a process and a threads, which is a process is when a program that is stored in memory loading into that is stored on disk and loading into memory and it's executed by the CPU, that becomes a process. So why am I explaining this, you might wonder? Well, because to understand now this stuff that we're gonna talk about in today's video, which is RxJS, like this, or this observability, this reactive programming in JavaScript, it's important to understand how do we get here. So to make it clear, well, now because these programs runs now, or they are stored on disk, in these programs are stored on disk and loaded into memory, and when the CPU executes that, it becomes a process. This process is what now allow us to run this program, this set of instructions. But this process, one of the important features is that it has its own memory address space. So other processes cannot interrupt the execution of other process because they are in their own memory space. They are self-contained. So one misbehaving process won't interrupt the others. So the anatomy of the, or some couple example of processes is like the program counter that indicate what is the next line to be evaluated, the stack to look at the function calls returning memory address or local variables, the register to know and to keep track is what is the memory allocated, and all of this now is something that browsers like Chrome are famously known to use. That anytime you create a new tab, a new process is created. So what is a thread? So a thread is this single unit of execution that, despite its fancy name, is just typically made of the program counter, the process, the program counter, the register, and the stack. Because JavaScript has a very unique implementation of this single thread, this conceptual single unit of work, all right? So here you have in JavaScript is the call stack, the heap, the global and function execution context, as well as the way of how it handles synchronicity with the event loop, the macro task, the micro task, and also the APIs that this language can have access based on the platform, whether it's on the web or on the node, on the server. So since JavaScript is a single thread, it means that it has one single unit of execution. So it is not uncommon for other programs to have multiple threads, but at least they must have one. And how now this process and threads are run, this is usually done by the context switching, or this is done by the context switching, where one process is switched off the CPU so another can run. Because the OS holds the state of the process and all of the data associated with that, and that is the memory address, and that is the process, the stack or the threads, as well as the memory space, right? So because this holding the state and keep track of that, as well as to update the proper data structure kernel and the memory size, is something that is very expensive doing this context switching between processes, unlike in threads, since now a threads live inside of a process and they now can share the same memory address, all right? So there is less state to keep track of. Now, there are several techniques that you can use to actually avoid to go with context switching, such as Fiverr and coroutines, where the point of this is to make this concurring or make this cooperating concurrency, right? So one process must be pass control so another can run. So I mentioned this because in the context of this asynchronicity, right, especially in JavaScript, and this is a single thread, and we have now tools to handle this using callbacks, and callbacks per se is show that it's not enough to actually handle with this new concurrency problems that we have to deal as the JavaScript developers, such as how do we handle with eventual value, a single eventual value. Hey, how now we deal with a value that at some point in the future we will get it, right? Only one. And the other is that how we're going to handle is series of eventual values, right? So we need some sort of tools or abstractions to help us here. Now, callbacks, we'll look at what callbacks is. Actually, we create a particular way of how can we handle is or concurrency with callbacks, that at the end of the day, we have to actually keep track of when we fire out several AJAX requests, we need to keep track of that when this response is resolved, so wait for the response to come back, show them in the proper order, and as well as handle them as they come in. As soon as they come in, we need to handle it. So all of this coordination that needs to happen is something that requires careful programming, and it also introduces some other problems, which is not only that callbacks are hard to reason because they don't follow the way of how we as a human plan stuff, okay? But also is this inversion control, because after all, you're passing a function, you're passing control to, in this case, set timeouts or timers to at some point you're gonna get that, right? So callbacks, as we look, it doesn't help us here to solve this particular issue. So now we look at thongs, which is a computer programming technique that help us to now is eliminate time as a concerning factor by wrapping that into a function. So you can look at this as a functional or a synchronous thunk, like that, or asynchronous thunk. And the idea is that we want to hold now a token or a reference, so by the time that value is done, we always get that value. So by the time we call that value, we always get that value. And in the context of a synchronous thunk, we pass now a callback to actually get that value once that is done. The TLDR of this is a thunk is just a function that wrap around the value so we can eliminate time as a concerning factor. And that is huge. That is huge, my friend. Because time is one of the most complex factors to manage here. So, even though it doesn't solve the problem of passing control or the inversion control, because at the end of the day we are passing this callback function, and whoever make that thunk, we assume that they are going to give that value without trigger too early or too late, or run too many times or too few times. Don't swallow errors, don't lose data context, and so on and so forth, right? We have all of this list of assumptions. Now, promise here and say, hey, this is now an abstraction that say, I'm going to handle this data or this eventual value, so you can eliminate again time as a concerning factor, wrapping around a value, a single value. So promise is also comes from the programming language called E, which is made by one of the TC39 members, Mark Miller, among others, where in that language they have this abstraction, they make this abstraction possible to handle that single eventual value. They call them features, and here we have something quite close called promise. So you can think of promise as this callback manager, right? Or this event listener that you can subscribe to this promise, and then by the time that data is there, under .then, you can get that value. And handle also is error handling. So with the .catch. So the idea is that promise help us now to define is flow control and data flow, right? However, even though that promise help us the callback inversion control, because now we make sure that we're gonna get that value, all right? That's what the promise was designed to be, that, right? Then we look at other particularly issues that promise doesn't help us here, especially is with this non-sequential, non-local reasoning. In other words, when we go with generators, okay, which is just a way of how can we describe syntactically state machines in the language, which is a series of, for those who are not familiar with that, state machines is a way to describe is series of flows from one state to another, to another, to another, to another, and then descriptively list the transactions out. Now, you can implement that for yourself, which is a great stuff. However, it turns out that it requires, again, careful programming. So, because with generators, we have now the ability in JavaScript to pause the execution of a function and then at some point resume, pretty much like when you hit the YouTube video and let's say you want to watch your favorite podcasts, right? Joe Rogan, Lex Friedman, Kim Kardashian, whoever, right? You know, instead of play that right away, you pause that, you make some popcorn, right? So once that is done, you come back and then you now resume the execution or play that, right? Resume that video. Now, this is quite similar of how now generators actually works. So it gives you now an iterator which allows you to control the generator flow control when you're going to get in or get out of this function, right? And also this generator, which is again another abstraction, another tool that we usually do that for stepping through a data, typically. So for example, when you now when you query a database, okay, a long database, and you split that by page, so anytime you go to the next one, you get the next one, the next one, the next one. So this is now a generator for that. It allows you to stepping through data step data. So in this case, we're gonna stepping through is flow control. This is mind blowing, by the way. This is mind bending stuff, bro. Now, so with this iterator, which is provided us by the generator, and then we have now control of this generator, we can also here by using is how we can now get in and get out or pause and resume the execution of this function by also passing data to this generator, to this flow state. We can then define is this different asynchronicity, or in this case, this asynchronous flow, which is something that we look at how can we do that, how we can actually is mimicking the behavior or replicate the behavior of the async in a way, using only generators and promise. And I think this is the next level of competency in JavaScript developers, to understand how the things truly works. So in any case, but the idea here is by looking at how you can do that behind the scenes, and also the plumbing needed to actually is now when you run that generator actually work as expected, fetch the data like that, but in this case using the yield keyword. This is great for now handling asynchronicity for single values in a synchronous blocking way of how we plan now stuff. However, what happens when we need to deal is with series of eventual value, which is another pattern that you as developer we actually have to deal with, right? So the point here is, since we don't have any native solutions right now to handle that, so promise here doesn't help us that much because it only solves is one single value, and we need to actually handle streams of values, all right? So for example, from mouse events or typing events, right? Which is a lot of the time, which as a UI developers we're doing, and then now perhaps from the user data, right? How can we handle and deal with that? Well, it turns out that promise by per se, it doesn't help us here. And even if we combine that with some sort of list context, it doesn't. So now here, the point of looking at observables is to understand now what is the value proposition, how do we get here, so we can understand and embrace this complexity. So these observables is pretty much like when you have a spreadsheet, all right? And on the spreadsheet, you can have values and calculated values. So in C1, let's say you put now 10, and then on C2, in cell C2, you put now is whatever value is on C1 times 2. When you hit enter, you get the value there. And on C3, you say, hey, whatever is on C2 cell times 100 or add 100, right? When you hit enter, you get the value that which is 200, right? So the idea of this is to look at this change of calculations, all right? And observables is now give us this ability to now work with this single unit of data that come from any source, right? Work with this single unit of data and then pass through a series of steps so we can distribute in our system. Why do we need that, right? Well, because this is, for example, when you want to handle this mouse events or typings or data that come from the server, you want to get this particular data. That's going to use now an example of the click, okay? So let's go with for example, the clicking here, right? Let's go for the click events, and let's say you want us to actually is that tag is just an X amount of click events in this short period of time. For example, 500 milliseconds or 1 second. So regardless how many clicks you get it, you just only want to trigger this once, right? So, but the idea here is that observables is the need that we have to a way to model is even data that come, this single unit of data that come from any source of data, pass through a series of steps so we can distribute that in our system. To put it technically, okay, so boil down into more technical aspect is that think of observables like hooking into an event source that produce a promise anytime an event pass through, okay, or an event comes through, right? So, because we don't have that natively in the language, we need to rely on this RxJS library like this, all right? And explore now what is the main use case for this and have a more practical approach to this. So RxJS, now you can think of this like Lodash for eventual values, all right, or for this concurrency. Okay, think of Rx of Lodash for events, right? And well, we explore now what is observables, how can we now create our observables, most of the time using the of and the from, and this of is for primitive or objects, and from is for array-like or iterators, generators, and even observables, all right? I hear you like to put observables into observables. So let's gonna put more observables into these observables. You know, it's like is like that meme. You know, it's like the then meme. You know, I think it's then. Exactly. It's like the damn meme, right? Some just like that. Pretty much that. Yo, then I hear you had some work to do, so I put some extra work in your work and added some more work to that. In this case, observables. So we went through that. We look at how can we create our own observables, and once you create this sequence of eventual values, we need to then is to listen to those, to subscribe to that. So this is the method that comes from the observables, and when we subscribe to that, we create now a new instance of these subscriptions. And how can we now is starting to use these observables? For example, we can create synchronous observables and asynchronous observables. So for example, with from, we can also use that with promise. And there's some nuance into that, right? As well as some of the common examples from, or some of the common methods that we can handle with to build our observables. So for example, from events, which is one of them, bind callbacks, from fetch, something that we're going to see that later, as well as intervals and time. How you can now tell to the observable library, hey, I want you to create now this series of, or I want to emit this series of data at an X amount of time, all right? Or I want to now emit this event or this data at this moment and so on, right? And then we look now at some of the common operators as well as to unsubscribing to that. So because at the end of the day, for example, useful for timers, an interval is like once that is done, all right, you just want to unsubscribe to that. Like, hey, after this series of, after I reach to this number, hey, okay, that'll be all, right? Or after a new period amount of time, hey, I want you to do that. So also we look at the subscriber function constructor, where it create now this subscriber contract, which is the way of how you can now is emit values, whether it's .next or complete or an error, and when complete and error happens, it will stop the execution. And then how you can now subscribe to that. So how you can consume that on the .next, on the .value, and on the .next, and the .error or on complete. So we explore here the most common operators here, all right? And that is the pipe. We also look at how you can create now a sequence of data of these eventual values, for example, using generators, right? And because we don't want to yield infinite numbers, we put now a sequence to that to say, hey, this is the amount of data that I want you to put this. And then the most common operators, right? So the pipe, for example, is like, hey, this allows you to run now an operator right after that. So this method takes one and more functions called operators, and each operator takes the observable, does something to it, and returns a new observable, right? It's also important to understand this, right? Each operator takes the observable, does something with it, and return a new observable. And this is similar to the method chaining or just piping in Lodash, right? Exactly, just piping into Lodash. But here is, instead of receiving is a function, it receives now an observable and return another observable, and so on and so forth and so forth. And the last element through that, it'll be now is a observable. So if we take a look at the pipe here, it will be now this. It will return now a unary function for that. So this unary function is a type to describe a function that has set one parameter on this, right? So this unary function, it returns you, at the end of the day, is that value as it is from this pipe, from this series of transformations. Okay, now, when we can use this? Well, for data manipulations, time manipulations, and multiple stream manipulations. This is something that I am not quite familiar with, all right? But let's get into this. Let's definitely get into this. So, a useful thing with RxJS is to space this over time. Take every end value. If they rage click in the user on the bottom, wait until they chill out a little bit, right? Before we can slam our API. Something actually helpful for that. So we also look at the take, which is something that you might use a lot of the time. Take. So hey, you take this certain amount of data and then stop and go home. Skip the first elements that match this. we can also have is the take while and skip while, and you have to be careful here because if one of them doesn't execute, it will never pass the observable to the another one, so it will never run. So for example, here you're saying, hey, skip while the value is less than 100, so skip the first 100 sequence value here, and then you might assume that, hey, I'm gonna take now the rest value. But the thing is that because this will never run, all right, at least for this 100 values, this won't take any effect on that. So this series of transformations that we need to pass, or this operator that we need to pass to the pipe, needs to be executed here. All right, we also look at map. It's great for single values, but becomes problematic with observables. And then you're gonna see that. Then you have now filter. All right, this just works like an array. It's like, hey, give me now is the, and from this sequence of data, give me now those that match this condition. In this case, odd, right? Again, filter and map are great for working with single values, but can be problematic to this observables. So then we look at the map 2. This is just a simplified version of map. And then we got Redux, scan, and tap. I just want to dedicate a little bit of amount of time to this, because this is, quite frankly, is something that we want to take a look here. All right.
So the reason that I point this out, basically be like an array reduce, similar, right? Reduce and scan. Cool. Reduce. Reduce is, there's two that are kind of similar, right? Reduce is, there's two that are kind of similar, right? Reduce and scan. I want to point out the difference between the two of them. We'll look at scan next. Reduce will basically be like an array reduce, very much so, where you will only get the final value when it's all done. Right? So we'll work through all the numbers. In this case, it's totaling them up. It will add them all in place, and then give you the final value.
It will give you the final value.
Scan will actually give you, every time it runs that reduce function, it will emit the value and pass it through. Right? So if you want
every time a reduce function is passing through, it will give you the value.
Every value is emitted, you'll get it all on the way. Reduce will only give you the final result. So the reason that I point this out is scan is usually
what you want.
Your brain a lot of times, because of arrays, will think about reduce.
Completely, man. Scan is what you usually want, because our brains works too much with arrays. But this is what you want. So scan is give you now the every value of every single reduce function, or in every calculation, it will give you now the value here. Where now reduce, it give you is the value after it passed through that, after all element has passed through that. Interesting. Interesting. Then you have a scan. That's right. Okay.
Scan is usually what you want, but your brain a lot of times, because of arrays, will think about reduce. So I'm like stopping for a minute and pausing to be like, no, you probably want scan, even if you're thinking reduce in this case. Scan can theoretically, you can take an infinite range, you can scan through it, but then you take 4, so on and so forth. One final one, which is everyone's best friend, is tap. We said before, pipe, one value.
Oh, tap, exactly.
X value, so on and so forth, right? Tap allows you to kind of have a side effect for a second and then return the same value you received.
Tap allows you to have a side effect like the manipulation and debugging. Okay. So tap. So you can think of tap like the middleware of Redux, right? What allows you to do is this these side effects. Even in use effects, right? Use effect allows you to run now side effects, right? So, for example, is if you need to interact with the browser API or to wait for some data to be loaded from a server, but use effect, you can think of this as each individual synchronization process. Again, this is tighten the notes, tighten the note, tighten the note, the note, tightening. Yeah, this is tighten the notes. No, this is Regan. Tight. Yeah, this is tightening the notes. Tightening. Yeah, this is tightening the knots. You know, it's like, oh, it's this one, and there's this one, and there's this one, and there's this one, there's this one, you know. That's what we're doing here, tightening the notes. Okay. I want to perform a side effect, then do this. I want to perform a side effect, and then go to the next one.
Why is this useful? Because if you don't have tap, here's what you're going to do. You're going to map where you console log the value and then return the same value again.
You're going to map, and you're going to
why is this useful? Because if you don't have tap, here's what you're going to do. You're going to map where you console log the value and then return the same value again. You don't need to live like that. You can just use tap, and you can console log the value. It's also useful for side effects that you want to do, because again, your subscribe will only get that final thing that comes out. It will not get any of the intermediary values, right? Yep.
Am I understanding correctly that top is essentially a convenience function where it takes in a value, operates on it, and returns that same value?
Operates and returns the same value.
Yeah, okay.
Exactly, exactly. It's like, I want to do other stuff, but I don't actually want to change this value in any way, shape, or form. Keep it going through. I just want to,
Same value.
Yep.
On, yeah, okay.
Exactly, exactly. It's like, I want to do other stuff, but I don't actually want to change this value in any way, shape.
Okay. For example, so I want to do
Perform. Keep it going through. I just want to, again, console logging alone is worth tap's weight in gold, even though it's code and doesn't have a weight in gold. But yeah, tap is useful for, I want to do something, a side effect of some sort, right? Because this pipe is, in functional programming, like it's a pure, it's a set of pure functions. Tap allows you to have a side effect. That could be console logging. It could be manipulating the DOM. Could be anything along the way. Anything you need to do that's not going to be the final value can happen in a tap.
Okay. So anything that don't influence the final value can be in a
side
tap.
effect. That could be console logging. It could be manipulating the DOM. Could be anything along the way. Anything you need to do that's not going to be the final value can happen.
Exactly. So anything anything. Okay. Or everything that is not the final value can be in a tab. Okay. I also want to have a more practical approach of this, at least the most common one. Say tab. So tab allows you to perform side effects. Okay. Useful for console logging. Okay, useful for console logging. Right? Okay.
Happen in a tap.
All right. Basic
mission
operator exercise.
is to get comfortable with some of these basic data manipulation operators.
Let's get into this. Basic operator exercise. Basic operators exercise. That's right. There you got it. All right, exercise basic operator test.
We have a kind of a series of tests that we're going to go through just to kind of like understand and see. Just again, like I said before, sometimes the syntax is a little bit different from what you might be used to. So this will kind of allow you to get a little bit of muscle memory and some understanding around that as well.
Yep.
And some understanding. Understanding is to get comfortable with some of these basic.
So get comfortable with some of these basics. Develop your muscle memory. Get comfortable with some of these basics. Develop your muscle memory. Pretty much.
Operators. We have a kind of a series of tests that we're going to go through just to kind of like understand and see. Just again, like I said before, sometimes the syntax is a little bit different from what you might be used to. So this will kind of allow you to get a little bit of muscle memory and some understanding around that as well.
All right.
So with that,
this is basic operator. The basis counter, basic operator operators. What about the operators? Basic operators. But what is the code? No. Okay. Anyway, well, let's take a look at that. It's this one. Portfolio, accent the counter, a client, mode, portfolio. Okay, that must be here. This one. Enterprise UI, that's right. Enterprise UI development. Fundamentals of frontend, no. Server side, intro v3, mock service. Eric's fundamental that you got it. Okay. Okay, so this is basic operators, like that. We explore that by actually creating them. For example, take, right? It actually creates now this particularly observable and to return that as a promise, so we don't have to handle that. So here we look at the take, map to do this. Another test was like you should skip the first values and double last two. So should skip the first value and double the last two. And if you want to apply now some sort of transformations to do that, you say, hey, I want you to map every value after that, okay, to whatever value I'm getting here. Come here. You got it? So like this, right? We already actually made this. And add the last year. It should emit the square of every even number in the screen. So if you want to get is the even number, we also can use the filter. Whatever of this sequence I want to only get is the odd numbers based on this condition, and then now apply some transformation. So map applies the transformations for all of these elements, and then it gives you that value. So by the time you pass now these observables, instead of actually consume that, because that's what it's doing here, is like, hey, I want you to now consume all of these values. and resolve the yeah, and once that is done, the result will be is the result which is something that now this promise is going to return, and then unsubscribe to that. Okay, so then you're gonna get now this sequence of data here. That's quite interesting if you want to get now how to make that work. We also looked at with scan to actually have this single values emitted for that. Scan or the Redux should sum the total of all of the Fibonacci number here. So if you wanted to get now the entire sequence of events or data and apply that transformations and get a single output, you do this, right? That's quite interesting. And you say, hey, should merge each object emitted into a single object, emitting each state along the way. So in other words, you want to emit each another state along the way. So scan is typically what you want here. So scan allows you to now take that value and work with that. Okay, so take that value and work with that. Exactly, take this single value, and then if you want to create that, or you want to compose that, you can do that. That makes a lot of sense. All right. Okay. Let's get into this.
Let's go and take a look.
Especially the last one.
Total, and we'll give it a starting value.
So if you want to compose it, okay, if you want to apply now a transformation to all of these elements and then compose that, you use a scan. So scan take this value and then give you the ability to now is compose that. For example, like this. And compose that scan through. So whatever each individual value you're going to apply that, you want is to now is create a single output create a collection of this single output here. Okay. So scan and Redux. Redux gives you the final output, the final outcome there. Where now scan can give you is now this different transformation that you have applied here. So you can think of this now as scan like some sort of Redux or this immutable data structure where you have now the ability to know what's happened before and after, or what happened as this state now change.
One of the things that we could do is having a starting value always makes sense. There is another value. And where reduce and scan can be somewhat interesting is it's one thing to total up some numbers. The other, with scan, you think about you can take an object, right? And then as things go along, as let's say actions, if you want to call them, go through the stream, you could take that object of state, take the object that comes through and figure out how you want to augment that object and effectively create a Redux reducer out of the box. So this could be interesting. If our counter got more sophisticated, and we're like, okay, by what interval do we want to count up? How, like by 5s, by 2s, by 1s, at what rate? Every second, every 5 seconds, up or down? What we could do is, if you've ever used any kind of like Redux Flux-like data store, you could theoretically use scan as every action comes through, manipulate the final state along the way, and you'll get every state transition, right, as you kind of go through as well. So that's where this can become somewhat useful as well. And what would that look like? Well, here we would have a pipe, and we'd say scan, and in scan we'd have the current state, and next, like this one's not using like actions with payloads, it's just kind of augmenting the object in this case. And we could go ahead and do everything that was in that last object and just overwrite anything that was in the next state. And we gotta put that in parentheses, otherwise JavaScript gets very confused. And
in the initial state.
Again, we've basically built a mini version.
The mini version of the Redux.
Just using the scan operator.
Everything boils down to Redux.
Through a series of values, right? You could call this action. It would work. You just have to do the stuff you normally do in a reducer. Like if action type is whatever, then do this state. But yeah,
this is the accumulator.
Effectively, you
and
can
the next
do
one.
a version of Redux in just a few lines of code. So yeah, those are some of the basic data transformation ones, right? Starting with simple and you can see how you might use this to kind of manage more complex things along the way. There are 2 more that I want to talk about. And these start to bridge the gap where we can get a little bit more sophisticated. And one of the reasons why I call them out is because just simply with their names can get a little bit confusing. Take while and skip while took some functions, right, that manipulated the values. But if you look in that example right there, in this case, it's not necessarily, there's not a function there. Skip until and take until rely on other observables, right? Which means when they show up, right, this observable will then subscribe to those observables, and basically it will skip. In this case, we have a timer that goes off after 2 seconds. We have a timer that goes off after 7 seconds, right? In this case, the interval is going to be pumping out values. However, it's going to skip them all until that timer goes off, until a value is emitted from first timer. Then it will start letting values through until there's an emission from take until, right? And then it will stop listening to any value. So effectively complete at that point. Now, if only somebody had a not great counter somewhere that was manually subscribing and unsubscribing to values. Turns out that we do, right? So if you think about it, I was manually
Okay.
subscribing and unsubscribing to values. Turns out that we do.
So here we have start time. First timer, second timer, example of interval. Okay, we create now this example that is going to run this sequence of data after 1 second. And we're gonna now subscribe it to, okay, 2 observables. First timer and second timer. Okay, skip until and take until. Okay, skip until and take until. So you have these subscriptions here. So skip until first timer, all right, so don't consider 1 until first timer, which is 2 seconds, right? And then take until the second timer, until 7 before 7, exactly.
Right, so
you are combining his 2 sources of data. Both of them now, you're combining 2 sources of data. Both of them now are timers.
That was manually subscribing and unsubscribing to values. Turns out that we do. Right, so if you think about our counter right now, we have the ability, we have those start and stop buttons that are emitting events, right, of any way, shape, and form, right? We have this interval that we want to start and stop based on those buttons. What my challenge for you is, can you rewire a counter so that it is skipping values until someone hits the start button, and it will take them until someone hits the pause button, right? Don't worry about too much about the values you see on the screen. The idea is we don't want it incrementing or at all, right? Whatever value it increments to, we don't care at this point. We'll fix that later. But what we want to do is remove that global variable and basically say we have the streams of clicks on those two buttons, and we will start counting and updating the DOM when the start button hits, and we will stop when the pause button hits, right? So we're going to use take until and skip until. We could use scan as well. That's a little bonus. Just worry about getting the DOM to like start and stop, and we'll figure out how we could also use scan as well along the way. So this, we didn't like this. What we want.
This is combining operator solutions. Okay, holy moly, bro. Holy moly, bro. Holy moly, bro. Here we go. So combining operators solutions. Or combining operators. So we have now is the okay. So we have now is the take until and skip until, take until and skip until. Okay, take until take until RxJS, that's right. Take until take until, okay, exactly, take until, take until here, so A, B, C, D, and no. Okay, I think this is RxG Marble, where now these things comes in handy, right? For example, take until. Exactly, take until. Take until. And take until and skip until. Skip until. Okay. This is the visualization. And skip until. This is skip until and take until. Okay. And this is until. And skip until. And skip until. And skip until. Okay. So,
two more that I want to talk about. These start to bridge the gap. So this, we didn't like this. What we want to do in this case,
all right,
is we want to basically use some of those new operators we learned about. take until and skip until. Again,
this is not the basic counter. So instead of our basic counter do this kind of stuff, okay, which is here, say git status, so git push origin, basic operators, right? Okay, we are now going to do this kind of stuff. Okay, but okay.
This still won't be totally perfect yet. Like I'll spoil alert, we'll have a single use timer by the end of this. But again, it'll be our first foray into kind of starting to combine different observables together. So we have the start and the pause.
Yeah, but let me go to the counter. So counter, basic counter application. Exactly, basic counter application. Here I want to now run this by say npm run all. Okay, so npm run all. And let's say npm the package JSON here. You look at this and what is this? Star npm run npm star or the UI. So back here npm star. But it say, hey, there is some error here, or not. No native view was found for this platform. But my app is listening at this particularly port, which is port localhost this. Oops, this one. This is the API, but what about the UI? Oh, npm run UI. It throws some error here because we are not using is the proper node version here. So no nvm less. I think nvm use version 16.1. I don't even do this. No, we didn't have that. We should. That's quite all, bro. All right. So if we run this npm run UI, now it's supposed to work as expected. So if we navigate to this, we are able to see that the server is now not running there. What is running is this, but I don't want to run the UI. I want to run everything. npm start. There you got it. Everything is running. All right. That's right. So basic counter. This basic counter is supposed to work. That's right. Cool. And the idea here is that instead of actually doing this manually, okay, by saying is that, hey, at some point I want you to now unsubscribe to this. What is the idea behind this? You know.
So this, we didn't like this. What we want.
What is the idea of using this take until and skip that and all that kind of stuff, you know?
There are two more that I want to talk about. And these start to bridge the gap where we can get a little bit more sophisticated. And one of the reasons why I call them out is because just simply with their names can get a little bit confusing. Take while and skip while.
Okay. Okay. Combining operator. This rely on other observables. Take until and skip until. Okay, it makes, okay. All right. Okay. Okay, so here we can subscribe to this, all right? And then say, hey, we can even create now like this.
So this, we didn't like this. What we want to do in this case, so this, we didn't like this. What we want to do in this case is we want to basically use some of those new
Use some of this, exactly. Use these new operators here.
This still won't be totally perfect yet. Like I'll spoil alert, we'll have a single-use timer by the end of this. But again, it'll be our first foray into kind of starting to combine different observables together. So we have the start and the pause. What we really want to do is create this counter.
The counter observable, exactly. The counter observable, which allow you to describe this sequence of eventual values, all right? And now run this on an interval after 1 second, and then you want us to now is to subscribe to this. Or let's say you want to pass now is this take while. Oh, okay. Take while, start this. So you take now only one, and then skip while.
Name a counter, which is that interval, in this case, of 1,000 milliseconds. And then now we
I
have
want
access
to pipe,
and what
and
we
then
could do in this case
is time count.
We could say,
so if you do this, if we do this now abstraction here, okay, that tells, hey, this new observable that is representing is a sequence of eventual values, all right? That in this case is a timer base. We want to put all of this, we want it to now get that value or take that subscription, take that observable. When they say take another source of streams, another source of events, and only take one. So take until you get that star, and then skip until and then skip until that.
That we want to skip until, and one of the things you have to remember to do is theoretically you can import them from RxJS, but if you care about your bundle size, what you want to do is any of the operators live in RxJS/operators. Skip until, we know we're going to need take until.
So they live is on side of the operators.
Operators. All right, so we'll skip until we get any kind of event that emits from the start button. And we'll
which is skip until start button, which is that don't take any value here.
We'll take them until we pause, until we get any event from the pause button. Again, this will be a single use counter. We're going to work on improving that. So we'll skip until, and then we will, once
that happens, skip until this observable is not emitting.
We'll then take until the pause button. And we're going to see one little bug that we have with this. One is that we're going to need to subscribe.
Exactly.
We'll do that set count.
So we need to subscribe to the set account, which is a function here to actually update that.
Where we will, Mark?
Is take until operator the best approach for management of subscriptions?
It depends, right? I'm going to argue with no, right, because we have a better way that we're going to get to. We just don't have all the tools yet, right, to switch in between different subscriptions. It's interesting because it will give you a time where a given thing should stop. One of the disadvantages of take until is that then it's complete, right? Once you hit the emission that gets you to take until, you're done, right? This observable has completed, and once an observable has completed, as we saw previously, it shall never start back up again. right? You have to replace it with a brand new one. Yeah.
Is this? I remember some talking vectors of hot versus cold
Yep.
streams. Is this related?
Exactly, right? Like this is one, like effectively this interval observable is single use, right? And it starts up when it gets its first subscription, right? Each subscription gets a unique version of it, and when it completes, that subscription is over, right? If a new one subscribes, it starts over from the very beginning. There's this idea of a hot observable, which is just going and keeping track of the many subscribers, and will only stop once everyone has unsubscribed from it. But here we have just kind of a simple one where take until will end this observable.
Exactly. It would take that and then only run
So
that
flip
one.
over and try it out. You see it start at 2, which is weird. If we get fast enough, it'll start at 1. We refresh and I talk for a few minutes, and I kill a little bit of time. See, it starts at 5, right? That's interesting. Anyone have a hypothesis why?
We're starting the generators.
Because we are starting is the set count. What is the set count, by the way, here function? Okay, pretty pretty simple. In that example, it's like we are not taking values out of this.
Code starts.
Yeah, exactly. It's the intervals are ticking along, right? We're not dealing with them. We're not letting them through the pipe until that first event happens, right? But they're going, right? So we need to figure out a way that we're in control, because interval will pop out, values one at a time, right? But what we could do is theoretically we could maintain our own state. Does anyone have a hypothesis on how we would do that?
With the scan.
Maybe. What did we do when we were maintaining state in those tests from before?
Scan.
Using
We're
scan.
using scan, right? Scan is super useful for that as well. So we can pull in scan. And we'll say scan, at which point it'll start with a value of 0. And we'll take the total. And really, we'll just do total plus 1. We don't actually care what interval had to say. We just know that we're going to ignore everything until you hit the start button. We're start.
Exactly. Ignore everything until you hit the start button. Ignore everything until you're starting to listen to this stream of events. Okay.
Or the value is 0, and we're going to increment by 1. So missed that comma there, and now we should be able to go back. And even if I can pause, I can refresh, I can talk to you all for a little bit and kill at least 1 second worth of time. And we still start at 1, right? So scan is useful for maintaining that state because, yeah, interval is popping out these numbers. We're always starting with 0, and only the ones they get to scan are going to increment that 0 at all. Now, we can't start this one back up again because, again, we unsubscribe.
Because we unsubscribed that.
Right. What we're eventually going to want to do is let start and stop basically change channels between the incrementing and silence, right? And so, cool, you want more values passed through? We'll go to that stream. You want to hear nothing because we're paused? We can go there as well. But we've got the state separated out. So we're getting there. We just need...
Mm-hmm. And this is now to combine is...
And we're going to increment by 1.
So this is if you want to okay, this is part of the hot and cold observables. Okay. So instead of having this subscription, we're gonna have our interval. In this case, we're gonna call this now a counter that is going to represent that interval, and same pipe, right? You say, hey, skip until the observable start emitting events, okay, which is start to listen to this observable streams of data, and then you want to scan each one of them. All right, I want you to start by 0, okay, and then I want you to start by 0, right? And for any value there, you can call this the accumulator and the seed, right? As they call here. Or you can call this accumulator and the current value. right? And then you want to say, hey, whatever you have in the accumulator plus 1. No, we're not going to use this now. Is the current value, all right? And I want you to now stop the execution of this observable by say take until the pause value. And then we actually need to subscribe to that by say counter dot subscribe, okay? And we're gonna pass now what we're gonna do by the time we run this subscription, which is the set count, which is now is this eventual value that we're gonna pass through this. So by the time that we subscribe to this, because it has somewhat the same shape of that, so the subscriber now as set is, you have it already? So the subscribe, I think allow me to go there. Anyway. So the allow me subscriber is set counter here. But then again, it's going to now pass that value as it is, right? As long as this subscription is alive. So by the time we go to this, say start, it will start that, right? We pause this, and when we hit pause, we unsubscribe to this. That's what happened. Let me actually take a screenshot here right now. And then record this. All right. So this only works is because, okay, here we create is a single observable. So we create is, okay, here we subscribe and unsubscribe to an eventual value to an observable once. Basic counter in a script. So git push, git commit with a message here that you got is the basic. This is now combining operators. All right. Question is that may I have the ability to add that, especially here. In basic operator, because the idea here is to now add that as it is, which is this silly example. Single observable. Okay. So, well, that'll be all for this video. Take care. Bye-bye.